Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you in lecture 18. I'm trying my best to finish that this example in lecture 17, but it's too much lengthy because these are very lengthy examples. So inshallah, I'm trying my best here that I will finish this example in this lecture 18. So I want to recap your memory, you know, that what we did in our last lecture 17. Basically, we just did calculations for two positive cutoff points, which is right over there, and two negative cutoff points, which is right over there. Okay, we calculate the location of this cutoff point of this cutoff point, I think, which lies a distance of 4 feet and 3 inches. Clear? 4 feet 3 inches from that space and 4 feet and 3 inches from this space. Okay, we find out its locations. Okay, then we comes here. There you can see we have 3 number add bars. We find out their location, that is 6 feet 3 inches from this side and 6 feet and 3 inches by this side. And similarly this one. We continue, okay, we continue these two number 6 bars into the supports. Okay, we provide splices over there because there are two number 7 bar and this is two number 6 bar. So we provide splice over right over the support. We cannot provide splice there. Okay, so this splice length is based upon number 7 bar, okay, which is 54 inches, and there we have same bars coming from that side, two number 6 and two number 6 bar. So we provide splice there, that is its length will be 37 inches. Clear? Now we continue rest of calculation. Okay, we did the calculation. We also check the shear criteria for this point and this point as well. That criteria is BU should be less than or equals to 2 by third of 5VN. Clear? And this criteria is satisfied. Clear? So let's see, we continue the rest of calculation. Up to this point, I think so it is clear. Now detailing a positive moment reinforcement in span AB. Now in span AB, if we look to the span AB, we see that this is span AB. So we have two number 7 bar. So this is clear that we do not cut any bar because ACI criteria is that you should need to continue 2 bars, okay, into the supports. So we cannot cut any bar here. Okay, we just need to check that we provide splice. So there is no need to check any kind of checking. We need to check this distance. Okay, and this is clear that we need to insert these two number 7 bars for a distance of 6 inches. Okay, and we check that whether we can provide hook or not. Okay, so structural integrity requirements govern the detailing of this reinforcement. In step 2, we provide continuity of the bottom reinforcement through column B by using a left splice length that was adequate for two number 7 bars in the span AB. Okay, I already mentioned you that at this point we provide splice. Clear? We provide splice, and that splice is basically on the basis of this two number 7 bar, that is 54 inches. Now comes to next point. The structural integrity requirement is also required that at least 1/4 of the reinforcement required at mid-span, but not less than 2 bars, be anchored fully into the external support at A column. We must check that the 16-inch square column at A is large enough to anchor the number 7 bar using a standard hook. Okay, this means that ACI criteria says that you need to extend minimum how much area? 1/4 area of the AST, positive AST. This is the positive steel area. Okay, this is the positive AST. So you need to insert, you need to insert into the support 1/4 area of this much of this area. But as this should be minimum, at least you will provide 2 bars. 2 bars must be extended, so that we cannot cut any area. So extended 2 bars into the support. Now we check that whether this is 16-inch column. Clear? This is 16-inch column, and we see that whether this support will uh, provide increase criteria or not, whether hook is necessary or not. Okay, so we just check it. Okay, uh, table A8 gives the development length LDH for a hook bar from the first part of 818 before applying any of the modification factors in SA code section list. The value of LDH from table A8 for number 7 bar 40,000 is taken as 16.6 inches. If we comes to table number A8, this is table number A8. Okay, this is in millimeter and this is in feet. So if we search out the development length of number 7 bar for 4,000 concrete, you can select 16.6 inch is the development length. But here this is only LDH. You need to multiply the factors. Okay, you need to multiply the factors. So see, okay, this 16.66 inches. Okay, this is, you know, to be able to be okay, we must determine a part A. ACA code section 12.5.3 can be applied for this case. Figure shows a plan view. Now we need to determine, because we need to multiply the factors, we need to multiply the modification factors. Now modification factor is that this side cover, this is the plan. I already mentioned you in lecture 7, 6, 8 when I was calculating the development length of hook. Okay, I explained these points, okay, clearly, that you need to calculate side cover as well as tail cover. Now here you can see that the total width of the column is 16 inches. So 16 inches, okay. So if you subtract 2 inches from 16, you have left spacing will be 14 inches. Okay. So tail cover must be equals to 2 inches. Okay. Now the side cover is determined, that is 4.875 inches. Okay, the beam dimension is given. You need to check because the beam dimension is 10 inches. So this is 10 inches and this is 16 inches. So this offset will be how much? 3 inches and 3 inches. Assume 1.5 inch clear spacing, and the stirrups, I think so, that is number 3 stirrups. So 0.378 will be subtracted. Okay, 3 plus 1.5 plus 0.38. Okay, it will give you 4.875 inches roundabout. Clear? So side cover is more than 2.5 inches. When side cover is more than 2.5 inches, clear cover is equals to or greater than 2 inches. Then you multiply this 0.7. This 0.7 factor will be multiplied. Okay, there it says clearly the side cover to the hook bars within the column exceeds the required minimum value 2.5 inch. This is 4.87. Also, if we assume the use of number 4 ties, if we assume that in this column we are using number 4 tie, okay, around the column longitudinal reinforcement, the cover on the tail of the hook, this tail cover will be equals to the required minimum value of 2 inches. Okay, this will be 2 inches. The reduction factor 0.7 will be multiplied. Okay, and then you can say the development length of your hook, final hook, will be 16.6 multiplied by factor, that gives you 11.6. So as the space is 14 inch and the development length for hook is 11.6 inch, so you can say there is no need of hook. no need of hook, but you can provide hook. Okay, if there is no need, you can provide standard hook 90 degree. Okay, so how this 0.7 is selected? Please revisit your lecture number 9 or 8, and that lecture we basically deal with how we can calculate the development length for a hook. Okay, and how we select this factor. It is based on side cover and tail cover. If it is less than 2.5 inch and it is less than 2 inches, we don't multiply. I think so 0.7. Okay, so I think so this is clear right now. Okay, now we this value is less than available length 14 inches, so therefore the bottom bars number 7 bars in beam AB shall be anchored into the column A using a standard hook. Now we will determine the negative moment cutoffs for the interior end of the end span. Determine the negative moment cutoffs for the interior end of the end span. It says that we will determining this point. Okay, this point. So for the sake of simplicity, you just this because we in the previous calculation we determined this length that is equals to 6 feet and 3 inches. So the bars are same, the lengths are same. So don't need calculation. Provide this length to this side as well. Okay, and I think so that did this. Okay, that did this. Determine the negative moment. So at the interior end of the end span, interior end of the end span means this point. This is interior end of the end span. This is your end span, or this is your exterior span as well. This is also called end span or interior span. Okay, end span, and this is your interior end. This is your exterior end. This is your interior end. This is your interior end. This is your exterior end. Clear? This point is interior end. Clear? Interior end, and this is exterior end. Okay, exterior end, and this span this is also called end span. Okay, this is also called end span. Clear? Now we can say that the moment point of inflection lies at a distance of 0.24 ln from the face of the interior column. Following the calculations of the negative movement bars in the interior span, we can cut the bars at same distance 6 feet and 3 inches. Because the point of inflection, the point of inflection is same here. The point of inflection as we did in the previous span. Okay, like that. There, this point of inflection lies at a distance of 0.24. And this point of inflection is also lies at a distance of 0.24. So the calculation which we did here is same for this point as well, because the number of bar is same and the dia of bar is same. So you can use those calculation here, and you select just only that spacing. Clear? 6 feet and 3 inches. Now we are determining the negative moment cutoff for the exterior end of the end span. Now this is end span and this is exterior end. We finding this location where we need to cut. This is the street area. Okay. Now we will do the calculation for this kind of point of inflection. Okay, this point of inflection. This. So there is the point of inflection. There is the point of inflection. This point of inflection lies a distance of how much? 0.24 ln. Clear? And it comes out to be how much? If you multiply 0.24 multiply by 20.8 is around about 0.66, I think so. 0.66. So comes out to be 4.95. This distance is basically 4.95 4.95 feet from the face, and you need to extend this points away from the support for a distance of how much? For a distance of d, that is 1.29 or 12 dB, okay, or ln by 16. Clear? ln by 16 is also 1.29, and this is lower value. So select this one. You add just 4.95 plus 1.29 gives you how much? Gives you 4.68 plus 4 feet and 9 inches. Clear? This will comes out to be, it is 4.68. Clear? This is 4.68 exactly. It is equals to 4.68. At this one you will get how much? 4 feet and 9 inches. Clear? 4 feet and 9 inches. Okay, 4 feet and 9 inches. Okay. It will give you 4 feet and 9 inches. Clear? You need to multiply this one. I think this is same. This is same. This is okay. 4 point multiply these two values will give you what value? We did this calculation here. Where it is? This 4.96. Okay, that is okay. Add 1.29 gives you 6.25. Okay, because 0.29 will multiply with ln, so it gives you 4.96. Clear? So for exterior end, there is number 7 bar. Okay, we will decide number 7 bar. That the top reinforcement in beam AB can be anchored in column A as shown. Okay, that basically deals with a negative moment point of inflection. Oh, this is at a distance of 0.164. Sorry. This point is basically at how much distance? 0.16. I'm wrong. I think so. I'm wrong. Where is there? This point is basically, you see there, this lies a distance of 0.1146. No? Where is this one? This one. Determining the negative moment cutoffs for the exterior end of the column, and it lies a distance of 0.164 from figure A2. If you, oh yes, that diagram doesn't work. Okay, you comes to graph A because this is exterior span. Okay, this is exterior span, and you see there 0.167. okay, 0.167. This negative point of inflection for the top bars lies at a distance of 0.164. So you need to multiply 0.164 with ln, that is 22.66, give you 3.71, and add the extension, that is 1.29, gives you 5 feet, exactly 5 feet. Okay, so here we are wrong. This is not exactly, this is basically 0.164 because this is exterior span, and for the interior span the point of inflection is different, and for exterior span the point of inflection is different for the same points. Okay, it will give you 3.7 roundabout. Clear? So you need to, if you need to okay, you need to just add 3.7 plus 1.29. okay, you will get the required, this one 3.39 is basically it comes out. you multiply these two with 20 point something, so you get 3.39 feet from the face of the exterior column. Okay, that it will give you theoretical point. You extend that theoretical point for a distance of d 12 dB or 11 by 16. So you add, because here you are at negative moment, and you are calculating the negative moment actual cutoff point. So you need to go beyond the point of from the face of support, not towards the support. Okay, so therefore you adding. Okay, it gives you 4.68, 4 feet 9 inches. That's will be your, and you need to check for an anchorage, you need to check for so this is for continuity, and now you need to check for anchorage. Okay, so here you can see that this is the actual cutoff point, which is lied at a distance of 4.68. Okay, this distance is 4.68. Okay, which comes out from 3.39, which is 0.164 multiplied by the ln plus 1.29. Now you need, let's check up in anchorage. Anchorage means that if this is the column and this is the beam. Okay, and you cut this bar, okay, at a distance of 4.68. Now you need to check that this length should be greater than, means 4.68 should be greater than or equal to LD. As there are, there are number 7 bars. I think so, 2 number 7 bar, 1 number 7 and 2 number 6 bar. Okay, there is number 7 bar. You will decide the development length on the basis of large. So you will check this this value. Okay, whether it is greater. So as we calculate LD for number 7 bar, that is, I think so, around about how much development length for the number 7 bar is 54 inches. So we providing 4.64 feet and 9 inches. So 54 is round about 4 feet 48 plus 9. So this distance is greater than this one. So the check is okay. Okay, this distance is greater than 54 inches. So this is okay. This is okay. Now next, therefore extend the top bars at the exterior end 4 feet 6 inches into the span and provide standard hooks into the column. The final reinforcement level is shown. Okay, and you also need to check this hook also. Okay, but as we checked in the previous example, whether we provide hook there or not. So as we did those calculation there, so the same calculation will be required there, and so anchorage criteria will be fulfilled. As the anchorage criteria is fulfilled there, so the same calculation will be, because there are also 2 number 7 bar. So as there is also number 7 bar present, so the anchorage criteria will be satisfied there. So you need to provide a hook there and a hook there. Okay, and you need to insert this distance, this bar for a distance of round about 14 inches. Although it requires 11 inches, but you insert 14 inches and provide a hook. Okay, if I draw it. Okay, so this is the column. Okay, this is the column. You need to insert the numbers 1 number 7 and 2 number 6 bar and provide a standard hook. This distance, this tail cover should be how much? This tail cover should be 2 inches. Similarly, for the bottom bars, there are 2 number 7 bar. This tail cover will be same, and this will be standard hook. Okay, and the distance, this is the distance, this is the development length. Okay, this required is 11 point something inches, but so you need to provide, okay, you need to provide 14 inches. You just, because 14 inches space is available to you if you are leaving a room of 2 inches. Okay, so this criteria will be fulfilled. Now we comes to see the final level. There is important points which is frequently Frequently, bending moment cannot be calculated with the coefficient in ACI code. Okay, because you need most of the time calculation is based upon standard methods. Okay, this is, you know, these moments on the basis of moment coefficients we do not calculate. Okay, we use slope deflection method or moment distribution method. You know, safe analysis we used. So basically, we use the exact method. This is the approximate method. Okay, this occurs, for example, in beam supporting concentrated loads. If the beam supporting concentrated loads, you cannot use this coefficient method, such as reactions from other beams. Okay, maybe there is, there is beams. Okay, there is possible that if there are other beams present towards these beams, so you cannot use this method. Okay. For continuous beams with widely varying span length, such as a case that may occur in schools and similar buildings where two wide rooms are separated by a corridor. Okay, two wide rooms are separated by a corridor means you have one room span, then other room span, then a corridor. So a corridor is hardly, it is around about 8 feet, and a room is wide, it is around about 25 feet. 25 feet. Okay, so here you cannot use these coefficients because the span variation is more. Okay, for such cases the bending moment graphs in figure A1 to A4 cannot be used. Here the designer must plot the relevant moment envelopes from structure analysis and ensure that the moment strength diagrams remain outside the required moment. The same calculation here, the designer did the same calculation as we did in example number 1 relating to cutoff points. Okay, as we did in Cormac book. We draw that exact diagrams. Okay, if I draw, let's say, the same calculation, they draw the exact diagram. Okay, this, okay, if this is negative movement, okay, this is positive, this is negative, okay, this is positive, okay, this is negative, this is positive, and this is again negative, okay, this is positive. Clear? Somewhat. Okay, when spans and loadings are different, sometimes you have maximum positive movement, sometimes you have lower minimum value, there is lower maximum positive value. Clear? There is maximum negative value. Okay, so you will draw this diagram, and then you, these are supports. Okay, this is support, this is support. Clear? This is support. So what we did, basically we did the the envelope diagram, which is, which is around about this, those envelopes diagram which we did, okay, in previous calculations. Clear? Okay, and this one. Clear? This one, those envelope, and these envelope diagram must envelop this actual moment diagram. So the designer then use these calculations. They actually do this process and calculate those inflection points, these inflection points. They calculate these inflection points. Okay, and then they provide those cutoff points. Okay. This is the end of this example. Okay, this is a simple example. I think there is nothing any difficult. You just need to find a fixed points. Okay, from graphs, we just determine the cutoff points for this number 7 bar, which is only 1 bar cut. There is no cutoff points because we continue all the bars. We provide there a splice. Okay, and this, we find out this cutoff point, this cutoff point. We just did the calculation for this span, and we provide that distance for this one, as well as for other points. Similarly, we did calculation for this span. Okay, and we check it for anchorage, for shear. Okay, and we also did the calculation for hooks. Okay, we did calculation for this side. Okay, and apply that with there. Okay, and the final diagram, if you want to see, the final diagram will be this one. Clear? You see that we provide two lapses. Okay, 1 bar is cut off at the mid portion at a distance of 4 feet from 4 inch from this side and 4 feet 4 inches from this side. You provide UV did calculation for this side and the same 6 feet 3 inches provide there and there. Okay. Then we don't need any cutoff point because there is minimum 2 bars, and SCI minimum criteria is that you need to continue minimum 2 bars to either side. We did calculation for this cutoff point and we provide 4 feet and 6 inches, which is more than the development length for number 7. We did calculation for this hook and we see that the development length of the hook comes out to be 11.6 something. Okay, and the space available for us, that is 14 inches. So this bar can be easily anchored in this column. Clear? I think this is the end. If you have any question, any doubts relating to this chapter, okay, because I finished this chapter, I cover all the topics. Okay, if you search out all the topics of this chapter, okay, I think I cover all the topics. I don't left any topic. Okay, this is the topics. Okay, we basically study the fundamental of bond. We study bond strength and development length. We study the different ACI code provisions for development length and tension. Okay, we study hooks. We don't study headed bars because in this area we don't use headed bars. Okay, so I left this topic. Okay, anchorage requirement for web reinforcement, I also explained this. Welded wire reinforcement, I left this topic. Development of bars in compression, I will study in lecture 16. Bundle bars are also ignored here. Okay, so they are used basically in precast. Okay, in our area we don't use bundle of bars. Okay, but remember, for welded, for bundled and for headed bar, the same calculation, same procedures are used, just only change the modification factor. Okay, so if you want to study them, that you can study that. Okay, because that is easy. There is nothing any difficult. You just change the modification factor. Okay, bar cutoffs, I covered this. I covered structure integrity provision, integrated beam design examples, and bar splices. So I think I covered it completely. If you have any question, if you have any doubts, uh, you have any you are not understanding any topic, okay, you can contact me. You can through my contact email my email is right on the screen. You can contact me and you can get any advice, any kind of information regarding this topic. Okay, inshallah, see you in next topics. I searching that what topic I will select for next presentations. Okay.